So yeah, the session's agenda is basically we're going to look at quickly what the challenge was, what motivated us to create this library, the approach we took, how we ended up designing it, and then we're writing a little bit of code to see how it works in action, as well as looking ahead on what we're planning to do with it in the future. So the challenge, what motivated us? This is a quote straight from the pitch document, from the ideas document that we had, and to quote it, it basically says Neo4j's products currently display graphs in varied ways, causing a non-unified look and feel. Product areas must duplicate work to develop visualizations, and customers are increasingly interested in embedding visualizations, which is not something we can currently offer, particularly with Bloom. So the idea was that we will use Bloom's underlying technology to roll out to other Neo4j tools. Bloom itself, it is to quote again, beautiful and expressive data visualization tool to interact and explore graphs. A humble quote from the Bloom website. So you can see here, it's powered by this graph visualization technology that we internally call Nevada. But that piece of technology has at this stage only been used by Bloom and never outside of Bloom, and it's been entirely developed and maintained by Bloom developers too. So yeah, the state of Nevada at the time was that there were two different rendering methods, a canvas renderer, which would allow us to draw text, arrows, and arrowheads and curved relationships, and then a more basic WebGL renderer, which would only have basic shapes like circles and lines, but would be extremely performant. So because it's GPU accelerated, we would switch to this renderer when zooming out and be able to display very large graphs. And in terms of layout, the two main features were the force-directed layout, also GPU accelerated, and a hierarchical layout. From a technical perspective, it was a simple JavaScript class that you could import, and then when you construct it, it gets a DOM element, an array of nodes, array of relationships, an object with certain options to define the environment and set the parameters, and an amount of callbacks that would be triggered when interacting with the graph. And of course, there were a bunch of methods to add nodes, remove nodes, fit nodes to the screen, those kind of things. Yeah, and now the idea was to use that technology and roll it out to other tools, because lots of other Neo4j tools also had graph visualization, but they were all using their own implementation. So to do that, the first thing we set out to do was to get some requirements from all these other teams. So the browser or query team we talked to, the ops manager team, who also have a hierarchical layout with different instances that you can manage. Of course, the query team had also little force-directed graphs that would display in all the tiles from the browser. Data importer has a nice interactive graph to create schemas and to draw graphs. And of course, we also had to check with our requirements in the Bloom team to make sure whatever we come up with is actually still working for us. So we talked to all the teams. We got a long set of different requirements. The main ones that stood out for us, particularly from the browser team, was that they needed many instances of the visualization running at the same time. Like in each tile, when you run a query, it would pop up a new little visualization, which was quite different from Bloom, where we just have always one large visualization instance and that's it. And also little icons and glyphs on the nodes to interact with them and give some information. The ops manager, some of the requirements particularly were to display very complex content as a node and also different shapes for nodes. For Nevada at that time only really supported a circle, and that's it for nodes. And the data importers requirements particularly were for very interactive manual layout to move nodes around, draw relationships, rather than any particular layout algorithms. So yeah, the list of requirements was very varied and quite long, and we struggled for a long time to figure out how can we actually cater for all these requirements, and is that even possible? And there was a bit of a crossroads of, well, we could just go ahead and add more and more features to Nevada and see how that goes. Just build this giant monolith that can potentially cater for all these different use cases. Or the other approach would be to just take it apart a bit, strip a lot of logic outside of Nevada, turn it into building blocks, and give the teams the flexibility to build something with that. Both approaches, of course, had their pros and cons, and it took us a long time to really figure out which way to go, because it seemed like such a fundamental decision that would shape quite significantly where we would go in the future. So that was really the major challenge, and that was something that we took a lot of time to figure out. So what was the approach? What did we do? First, we kind of mapped the pros and cons out on this little matrix of, well, feature-heavy monolith versus a configurable building blocks. What are the pros and cons? So in terms of the monolith, of course, it would be a bit easier to integrate for all teams. It's just this giant library that you import, and it works out of the box. It's got everything out of the box. It would provide that consistent look and feel across the tools. Probably less unexpected behavior with all the integrations. Then, of course, it would be on the downside. Well, that's a lot of things to document, a lot of things to implement on our side as well. And we were still not quite sure if such a library even exists, like, or if it's even possible to build this giant tool that would have all these features that we needed to have. On the other hand, if you made it flexible and extendable, it would most likely be suitable for all tools and easier to maintain for us. But then it would be a lot of work for the teams to implement and maintain kind of the solution that they come up with. And then as we sort of kept slicing and dicing the library and thinking, how much more can we compartmentalize this so people can use it for all these different use cases that there are, we realized if we go like this basic on a level, and everyone kind of has to pretty much build it from the ground up, then like what's the whole point of the project? Everyone is going to end up with their own implementation of the project, and then they won't be really indistinguishable from another. So yeah, we weren't really any further at that stage, so we started mapping it all out. We went on a Miro board, listed all the requirements. I'm not going to go into too much detail on this one because it's just a lot of information, but just to sort of give you an overview, we went through all the requirements from all the tools, mapped them out. We looked at the code base of Nevada currently, how it looks, mapped it out in a Neo4j graph, and so how all the files are connected, what configurations are there, and how could we align them on sort of the spectrum of being fully flexible and kind of fully feature heavy, but working out of the box. And in the end, we came up with an approach with 2 layers initially, later 3 layers, which is the design of NVL, which I'm going to talk about now. And the 3 layers in the end were the core layer, the React layer, and the interaction handlers. So the core layer is very much the current Nevada, the previous Nevada library, being completely stripped of any kind of opinionated logic, opinionated interactions, being very much just the base technology of how the layout works and how the renderers work. So with that would give you the flexibility to build anything from the ground up that you would like. So any team or any external customers that we might want to share this in the future would be able to build any tool they want, but they would have to build it from the ground up. And then on top of that, we were developing React wrappers for the teams that would contain all these opinionated behaviors, interactions, when to switch renderers, how to render nodes, all these kind of things, and provide some sort of React components that just work out of the box, basically. And this is then in the end what we started using internally within the teams. And on top of that, we also developed a collection of interaction handlers that would have some basic and some custom interactions that we can easily add to the core library or the React wrapper, so we can sort of mix them together a bit. And how these are all interconnected, I was going to show now. I have a little Neo4j database here. Just double checking that I'm also still live. Yeah, that looks good. So here we are. In this little graph, I have mapped out the of how the current NVL project looks like. NVL is now the new name, like it used to be called Nevada. We're calling it now NVL, or Neo4j Visualization Library, just to mention that again. So yeah, here are the 3 libraries that are basically contained: the core library, the React library, and the interaction handler. The most basic way to import it would be by using the core library. So if I have my parent application, it would then import the core project, which its main export is the NVL class. Documentation of everything, it's done with type doc. So we're using doc strings and then export this little website, which has everything nicely documented. It's very handy. That's also what we provide to our customers with this library when we send it out. And the core library is set up very similar to how Nevada used to be set up. You give it a DOM element, some nodes, some relationships in an array, options and callbacks. And that is pretty much it. There's no, it just renders you the graph, and then everything else you have to build on top by hand. There are a lot of helper methods that are provided here to add things and so on. We'll do a little bit of coding later to go a little bit further into that. But that's the most basic way of using it. If you want some interactivity to work out of the box, if you don't want to implement it yourself, it's possible to use these interaction handlers. So they would, here we are. Yeah, you can just integrate them together with the core library. So if we look at the documentation here, after creating your NVL instance, we can create a new click interaction handler, and then that will provide you with a collection of callbacks such as canvas click, node click, and so on. So you don't have to identify those things by hand. It's all coming from here. And now finally, if you want to also use it within the React framework, we've got the React wrappers. That would then, there is, dismiss this one for now. So there is the basic React wrapper, which is imports the core library and then just wraps it. So if we look at that, it's pretty much similar to using the core library. It gives you, you just provide it as properties instead of arguments in the constructor. And then it will automatically, every time those properties update, it will automatically call the relevant NVL methods to keep the visualization library up to date. We look at how that works in a little bit too. And now if I want to use all of that out of the box, then I can use, we've got another React wrapper that pretty much incorporates the, so if we expand this. Here we go. Let's dismiss this. It incorporates, so it's based on the basic React wrapper, but it also imports all the interaction handlers, and that is sort of the most complete way of using it, kind of out of the box experience of the NVL application. So this setup here is pretty much how all the teams are currently using it. But if that was too opinionated in some way, you can always go back to the basic wrapper or build another wrapper based on the basic wrapper that uses different interaction handlers or custom ones. Yeah, and if you're not wondering why about making a Neo4j graph with 14 nodes, there is a little bit more in this project too. I've also mapped out all the files that are part of this project and how they are like being imported with each other. So I think the force-directed layout makes a little bit more sense here. So yeah, we can see the React wrappers. It's just a bunch of wrappers and some hooks. The interaction handlers are also only a collection of classes for each interaction behavior, and by far the biggest logic is here in the NVL core library. So yeah, that's like a little fun side project where we can map out the code and sort of see how it all relates to each other, and try to sort of entangle some of these files sometimes. Yeah. Now, oh yeah, and what I'm also quite excited to show actually is here in query. If we go into query, you can see that it is already using the NVL library. So it used to be, this was the previous visualization customly built by the query team. And now here under the experimental flag, we can already see the new way of doing it, which is using the NVL library and the React wrapper, which is super. I'm very excited about that. Yeah, for the last few minutes that I have left, oh no, I actually have a little bit more time left. Yeah, let's look at some code. So I have a little example up right here, which is what we also provide together with the library. It's a collection of examples that showcase how to use NVL, so how to use all the different styling properties. There is a feature that allows the user to overlay any HTML content on top of the nodes. So how that works. Also some other projects, how to make captions, how to test it here. This is a test on just checking that it sort of still works on the large scale. This is a 10,000 nodes graph. You can see it whole entangled in the physics layout, or we can switch to the hierarchical layout to see that that all works okay. You can switch between the rendering methods, so WebGL or the canvas renderer. Yeah, but what I want to do is really just make some very small scale examples. So what we have here is probably the most basic setup really for NVL. We have a constructor. It gets the parent container, which is just an HTML element, an array of nodes, an array of relationships, and then I get this. So I can't do anything. I can't scroll or click. It's really just that graph with a force directed layout. Now, if I want to start adding some interactivity and actually engage with this graph, yeah, with the core library, I would have to do that very much from the ground up. So if I here and turn it at the end, and now I basically have to just in a classic way add my event listeners. In this case, it's just a click event, and then yeah, based on that, let's make an action. So if the most basic way is the add and update elements in graph method, which for any new, it will add any new nodes that you give it and update any existing nodes. So in this case, if I just want to add another node, I'll give it an array of nodes here. So ID, do 2, new node, and then let's add one new relationship as well. IDs are, yeah, can be any string. Basically, you just have to be unique. And we give the from property, 1, 2. And now click. There we go. Oh, no, that was the wrong ID. Let's try that again. There it is. Now, if I actually want to engage with my graph and not just, general clicks anywhere on here, I can do that with the NVL method get hits. So I have this method in my NVL class called get hits, which will give me information about what was actually under the event. And what it takes as an argument is just any mouse event, can be mouse move, wheel event, click event in this case. Let's just log it as well, so maybe we can inspect it a bit. But the idea is pretty much it gives me what nodes and relationships was under the event and how far was it away, the vector between the cursor and the element and so on. So targets nodes, so if there were any under my cursor on the event, I wanted to make a different update in this case. Use the existing node and just turn it red. So again, I can just use the targets that I have. And what I have to provide for the update is the ID and then what properties I want to update. So in this case, ID is the ID of the node that was the event under, and let's just turn the color red. I don't really want to update any relationships, and let's wrap this other bit into an else clause. Yeah, let's see if this works. But this is the basic way of setting up interactivity. So node, red node, there we go. Yeah, but still no zoom or anything or panning or anything like that. If I wanted to do something like that from scratch, just to quickly showcase that too, I can just add a wheel event. Current zoom from my NVL instance. Lay the noon zoom by using the current zoom minus the events within that is 2. Oh, now I want to see what I'm doing wrong here. That's better. And then I have to set my new zoom. Zoom. This would be like a most basic implementation of zooming the graph. There we go. Yeah, you can see it conflicts with the pages scrolling as well. So if I just want to have that all out of the box and don't implement that all from scratch, I can make use of these interaction handlers that I mentioned earlier. So these are decorator classes, zoom interaction, pan interaction, and I just have to initialize them with the NVL class. And now I should get zooming and panning working out of the box here. There we go. Yeah, so this is the most basic setup, really. I'm showing this just to show that you can basically, that there is no opinionated interaction. You can, it's possible to really build it from the ground up in whichever way, whichever events, whichever sort of experience, you know, the teams or any customers of ours would want to create with this. Now, if we want to use React, there are wrappers here too. So this is basically the equivalent in React now. A very basic setup. We just provide the nodes and the relationships as properties. I've got my graph here. Yeah, very basic graph again. I've got it here in state. And if I want to do the same thing of just adding nodes to it on click, we just add the event handler here on the property itself. And now instead of calling the methods of the NVL class, I only really need to update the properties and the wrapper will do it for me. So in this case, I just update the graph in the state. And what I want, I've got the nodes, basically want to keep the nodes that I currently have. And add one more node. In this case, just incremented string. Yeah, relationships can just stay the same. Okay. So in this case, if we go back to the React tab, here we go. Similarly with the options can be provided here. So if I, for example, if I want to change the rendering method, I can do this by using the option use WebGL. If I set this to false, for example, it would use the canvas renderer, which provides text. Little typo there. And here we go. Now we can see here teeny tiny text. If I want to update this, I can also just put that in the state, and then whenever the properties of my component update, let's set this to start off with false. So you now use this value, and here let's add another interaction. Let's say on context menu, go on right click. Sure, the context menu doesn't actually open, and then we just set use WebGL to its current inverse. And now I should be able to just switch the rendering method by right-clicking anywhere. So yeah, what the React wrapper there provides me is basically just, it always makes sure my NVL class stays up to date as my updated props comes in. So that's like a lot of work that all of our teams would have had to do just with the core class, like having to build their own React wrapper. That's basically taken. They don't have to worry about that. Yeah, and of course, if you want any of the sort of standard interaction methods, you can. Oh, one thing I actually forgot to mention. Yeah, at the moment, the NVL class itself kind of obscured by this React wrapper. But if you do want to access NVL directly, you can do that by providing a reference. Almost forgot that part. So if we create a NVL ref by just using a classic React ref and pass that in as a ref, then I am able to here access that and say fit the nodes of my current graph. The fit method takes node IDs, an array. So in this case, I have to really provide the IDs. So now it will always fit my nodes into the graph whenever I right click. There we go, and change the rendering method as well. Yeah, so much for that. If I now want all the interactivity that sort of comes with common graph experience, I can use just a different React wrapper that's currently provided. I call it the interactive NVL wrapper, for the lack of a better name. So that collection of React wrappers is hopefully about to grow in the future. So now instead of adding my custom event handlers, I just add mouse event callbacks from the interaction handlers directly. I don't even have to add a specific callback. If I just want the behavior, I can just give it a Boolean. And then yeah, get sort of all the common interaction stuff out of the box. And this, yeah, like I said before, this is sort of the wrapper that most of our teams really use, and it's the easiest to get started. And yeah, with this whole approach, really the idea was we've got the core library if you want to build something completely from scratch, but we've got the React wrappers if you really need like an out of the box experience that just works. And that's how we at the end tackle this challenge. All right, I'm going to get back to my slides to wrap this up. Where were we? Demo, looking ahead. Here we go. So now, yeah, as you can see, it's already available in query. We're still in the process of rolling it out across the other tools, and we're getting a lot of feedback, and it's still ongoing project. So as that's happening, we're involving the library as we integrate it into our tool stack. We've sent it out to some early access customers too. So we're very, very excited to get some feedback from them to see how they use it and what they're missing. And in the meantime, what we're working on is mainly continuously always improving the layout, the performance of it, and also the quality of it, as well as the rendering performance too, particularly for large scale. And that is the end of my presentation. Thank you.